esterification. Esterification is a chemical reaction between carboxylic acid and alcohol to form an ester and water. The esterification reaction is reversible and reaches an equilibrium. So methods such as using excess reactant or removing water are applied to increase the yield. As for this slide, the image demonstrates a typical reflux setup used in ester synthesis, which is allowing the reaction to proceed efficiently while collecting the product, which is ester, at a minimal loss and maximum safety. As for the esterification reaction, we use catalyst, which is H2SO4. Why we choose H2SO4 as the catalyst? Because it is strong acid and it can remove water to shift equilibrium, and also it can speed up the reaction. The reaction usually take about 1 to 4 hours with temperature 60 up to 80 degrees Celsius at atmospheric pressure. The image highlights the importance of the esterification reaction by showcasing its application in various industries, specifically in fragrance and flavor, pharmaceutical and polymers, as well as cosmetic and personal care. In the fragrance and flavor industry, esters are widely used due to their pleasant fruity aromas. For example, ethyl butanoate gives off a pineapple scent, while isomethylene acetate smells like bananas. These esters are commonly found in perfumes and food flavoring. In the pharmaceutical and polymer industry, esterification is essential in the production of medical compounds such as aspirin, which is made by reacting salicylic acid with acetate anhydride. Additionally, esters are used to produce PET, a type of polyester commonly used in plastic bottles and food containers. The image also emphasizes the significance of ester in the cosmetic and personal care industry. Esters are valued for their smooth texture and fragrance, making them used in the formulation of shampoos, lotion, creams, and lipstick. Overall, this reaction is crucial for creating a wide range of products that are used daily life in modern life.
So hi guys, this video I will explain esterification mechanism. So as you can see, this is a general equation which is between carboxylic acid and ethanol. Present concentration of acid sulfuric produce ethyl acetate, which is as ester plus water. So firstly, we focus on mechanism. In this mechanism, I use acetic acid as a compound. So this acetic acid present of lone pair electron on oxygen, right? So you can see this is a lone pair of electron. So this oxygen attack the proton, and this proton from acid sulfuric, which is, you know that acid always give a proton whenever we are adding to high water. So here, this is a lone pair. Attack proton will produce protonated ester. So this is a protonated ester. So as oxygen is donating its electron, it's getting positive charge. So now what will happen? We need to nullify this positive charge. In order to nullify this positive charge, we will shifting these double bonds towards oxygen. So this is we shifting this double bond towards oxygen, and the positive charge getting nullifies. So next, positive charge on carbon. So you can see formation carbon cation is attacked by alcohol. So this is alcohol, and we know oxygen is having two lone pair electron, right? So oxygen donates electron towards carbon. Whenever it's donating electron to carbon and oxygen, it will produce bond formation. So as oxygen donating electron, there is positive charge on oxygen. So next, in order to nullify this positive charge, we will shifting this bonded electron, this oxygen and hydrogen towards oxygen. So next, positive charge nullify these hydrogens and get positive charge. So now the positive charge on hydrogen is attracting by OH. Is attracting by OH where the oxygen. So and where the oxygen having lone pair electron, it will produce OH2 plus. So next, OH2 plus, we need to nullify this positive charge. We shifting this bonded electron towards oxygen. OH2 plus charge is nullified and liberated out as water. So next, carbon gets positive charge, and we need to nullify this positive charge again. So here you can see for H, we're shifting these bonds towards oxygens. So these hydrogens comes out as hydrogen plus and negative charge on this. So negative charge on these oxygens. When negative charge on oxygen and positive charge carbon together will form the final product. Produce acetate as final product. And this proton liberated out in formation of hydrogen plus. So that's all. Thank you. Okay, so for the application in esterification process is mostly used in making of perfume, such as that shown in the slide, making paste marine ester for ethyl ethanol. So chemical involved is ethanol with acid, ethanol, concentrated sulfuric acid, which is catalyst. And procedure: firstly, measure 1 ml of ethanol and 1 ml ethanol with acid into test tube. And then we add a few drops of concentrated sulfuric acid carefully, and then mix gently and place the test tube in hot water bath. After heating, remove and let it cool. And then pour into a beaker of cold water and gently swirl. And lastly, smell carefully by wafting. You should notice a pleasant fruity sense of ethanol similar to pear drop. And for the ethyl ethanol, it smells like fruity like pear. And for methyl butanol, smells like pineapple. And lastly, for isoamyl acetate smells like pineapple.